Triangle EFG is inscribed in circle C, and segment EF is the diameter of circle C. If the radius of the circle is 2.5 feet, GF is 4 feet, then the length of EG is blank feet, and your answer correctly is the number that fills in the blank in the previous sentence. Okay, well, we know that since this is a diameter, then that this angle is a 90-degree angle. We know that 90-degree angles in a triangle creates right triangles, so we could use the Pythagorean theorem, which would be a squared plus b squared is equal to c squared. Now c is the hypotenuse, so it would be this length of the diameter. How can we find that? Well, we know that the radius is 2.5 feet, so we know from E to C would be 2.5, and we know from C to F would be 2.5. So total, this would equal 5 feet. We know that GF is 4, so this could be labeled as A or B, it does not matter. So we have 4 squared plus something squared is equal to 5 squared. So 4 squared is 16, 5 squared is 25. It's a much easier, so if I actually just jumped over, this is an algebra calculator by Symbol Labs. It shows it out a lot cleaner than what I could do. A squared plus b squared is equal to 5 squared was what our original formula was. So again, they're starting it out differently, which is completely fine. They're subtracting the 4 squared from both sides, and then they simplified 5 squared minus 4 squared simplifies to 9. And then for x squared is equal to the function, the solutions are the square root of that and the negative square root of that function. So you square rooted 9, so b is equal to the square root of 9, and b is equal to the negative square root of 9. So now let's come back to our thought. Can our distance be a negative length? The answer is no, our distance cannot be a negative length, so our distance is the positive 3.